last screencast was about the elasticity of demand, and by far that's the most important kind of elasticity. In this screencast, we're going to cover three other types of elasticities, which between you and I aren't nearly as important in terms of the AP exam, but they do pop up, and so here we go. Alright, first off, we're going to talk about the elasticity of supply. Now this concept is very similar to the elasticity of demand, but now we're talking about from the producer's point of view or supply. We're going to see here that the primary determinant of the elasticity of supply is time, how much time producers have to adjust to what's happening in the market. The formula looks similar. The percentage change in quantity supplied instead of demanded of a certain good divided by the percentage change in the price of that good. And again, we're going to take the absolute value of that number. Now, we're going to start off with the very shortest time period possible. We're going to call that the market period. I want you to think of that as the time period in which producers don't have any time to adjust how much stuff they have or how much stuff they produce. Here, supply is going to be perfectly inelastic, which is why it looks like a straight up and down line. Think about like a turnip farmer who's brought 100 turnips to the farmer's market today. Today might be the market period for that turnip farmer, because no matter what the price is, they only have a certain amount of turnips, 100, and it doesn't matter whether people are willing to pay a penny or $1 million. There's nothing they can really do about the quantity that they have to supply. Now that's important in terms of the impact on the market, because when we have perfectly inelastic supply, when demand changes, we tend to get relatively large price changes. So for example, if that turnip farmer brought his turnips or her turnips to the market, and demand were to go up, we would see a large increase in price. You can see what happens to the equilibrium price here. Because producers haven't had time to adjust their production, that change in demand is being translated entirely into a change in price. There is no change in equilibrium quantity. There was only 100 turnips there to begin with. If we give that farmer a little bit longer time to adjust, we'll call that the short run. And for now, I want you to think of that as the time period in which producers can change small things about their business. Maybe for a farmer, it might be a few weeks or a month. Here, the farmer has more ability to adjust the quantity that they produce, and so supply becomes a little bit more elastic, a little bit flatter. The farmer can't change huge things about their business, but if they think price is going to go up, maybe they can add a little bit more fertilizer or squeeze in some extra rows of turnips in the corners of their fields. And again, that has an impact on equilibrium price. Because now if demand were to increase, price would go up, but not quite as much. And we would see a little bit of an increase in the change in equilibrium quantity. The farmer was able to produce a little bit more. If we give that farmer an unlimited period of time in which to adjust, we'll call that the long run. And for now, I want you to think of that as the time period in which producers can change anything about their business that they want to. It's going to have even more dramatic impacts on the market. So for example, with our turnip farmer, if we tell him or her that 20 years from now, turnip prices are going to go way up, well, now the farmer can go out and buy new land, plant new entire acres, buy more equipment, change big things about his or her business. And so now if demand for turnips were to go up, we'd see an increase in price, but it would be a lot smaller. We get a lot bigger increase in quantity because that farmer has had time to adjust to those price changes. Okay, so that's elasticity of supply. And you really don't need to know it as in-depth as you do for demand, but know that the primary determinant is time, and that the flatter that supply curve is, the less dramatic price changes we get when demand changes. The second kind of elasticity that I'm going to talk about today is called the cross-elasticity of demand. It's a complicated name that deals with a relatively simple concept. This is a kind of elasticity that will help us determine whether goods are substitutes, like Coke and Pepsi, or whether they're complements, like peanut butter and jelly. Remember, we saw those concepts a few screencasts back. Now, the formula for the cross-elasticity of demand is the percentage change in the quantity demanded of one good, like Coke, divided by the percentage change in price of another good, like Pepsi. Now, whereas the elasticity of demand, we took the absolute value of the number, we didn't care about plus or minus signs. For the cross-elasticity of demand, pretty much all we care about are plus or minus signs. We're not taking the absolute value of this number. If we use this formula and we get a positive number, we know that the goods are substitutes. So think about it. Let's say the price of Pepsi goes up by 100%, right? Pepsi's more expensive. What's going to happen to our demand for Coke? We're probably going to buy more of it. They're substitutes. We won't buy as much Pepsi. We'll buy more Coke. So that denominator is a positive number. The price of Pepsi went up by 100%. And we can expect that numerator to also be a positive number because we're going to buy more Coke. On the other hand, if the number we get is a negative number, we know that the goods are complements. Let's talk about peanut butter and jelly. Let's say that the price of peanut butter goes up by 100%. So that denominator is a positive number. Since we always eat peanut butter and jelly together, we're probably not going to buy as much jelly. That numerator is going to go down. Negative number divided by a positive number is going to give us a negative number, and we're going to know those two goods are complements. If, on the other hand, the number we get from this formula is 0 or near 0, it means that the goods probably aren't complements or substitutes. Think about things like, I don't know, gum and computers. Let's say the price of computers goes up by 100%, so that the denominator is a positive number. What's going to happen to our demand for gum? Probably not much. They're not really related. That numerator, the percentage change in quantity demanded of gum, is probably going to be about 0. That'll give us a number of 0 or close to 0, and we know that computers and gum aren't related. All right, so here's a typical problem. Suppose the cross-elasticity of demand for products A and B is plus 3.6, and for products C and D is negative 5.4. What can you say about goods A and B and C and D? Pause, come up with an answer. That's simple. If the number is positive, like between A and B, we know A and B are substitutes. If the number is negative, like between C and D, we know the goods are complements. All right, I'll give you a slightly more difficult problem because I'm not giving you the number in the formula. You're going to have to figure out the number. Suppose the price of good E rises 10%, and that results in the quantity demanded of good F falling by 20%. What can you conclude about the relationship between products E and F? Again, pause, calculate, come back. Well, plugging them into the formula, the numerator here would be negative 20%. The denominator would be positive 10%. That's going to give us a number equal to negative 2 for the cross-elasticity of demand, and we know that these two goods are complements. All right, final kind of elasticity we're going to talk about is called the income elasticity of demand. Again, a relatively complicated name for a relatively simple concept. This elasticity will determine whether goods are normal goods, like steak, clothing, trips, cars, or inferior goods, things like spam, bus tickets, lottery tickets. Remember, normal goods are goods that you'd buy more of if you had more money, or buy less of if you had less money. Inferior goods are goods that you'd buy less of if you had more money, or more of if you had less money. If I get poor, I buy more spam, I don't buy quite as much steak. All right, again, here we're going to be concerned with the value, whether it's positive or negative. We're not taking the absolute value of the number anymore. Here, all we care about is whether we get a positive or negative number. The formula for the income elasticity of demand is the percentage change in quantity demanded of the good divided by the percentage change in someone's income. If we get a positive number, we know the good is a normal good, sometimes called a superior good. So for example, if I get a doubling of my salary, that denominator is going to be a positive number. And if I find that I buy more steak, that numerator is also going to be a positive number. I know that steak is a normal good. If the number that we get is a negative number, the good is inferior. If my salary doubles, denominator is positive, and I find that I buy less spam, the numerator is negative. Negative number divided by a positive number will give me a negative number. Again, I'll show you a couple of examples. Let's say that Joey gets a 10% raise at work, and over the following year, the quantity of bus tickets Joey buys falls by 20%. First question, what is the income elasticity of demand for Joey? Secondly, what kind of good are bus tickets for Joey? Calculate, think, pause. Here's the answer. Plugging the numbers in, I get a -2 number for the income elasticity of demand. And since that number is a negative number, I know that bus tickets must be an inferior good. All right, that's it for this one. See you next time.
Oh!